G'day chemistry students. In this video, we're going to be covering dot points 6.1.2 and 6.2.1. In particular, our focus today is on unpacking all the different kinds of ways that we can measure how acidic or basic something is using indicators. Let's get into it. So first off, there are a variety of chemical indicators. You can find tables like these, which sort of outline them all. What you'll find is that most indicators have this pH range, this range in which there is a turning point. You may even find a more specific endpoint, a point of pH, where the indicator will change from one color to another. So, for example, methyl violet will change from yellow to blue as it progresses from a pH which is less than 0.8 to a pH which is more than 0.8. This can give us an indication of how acidic that substance is. So methyl violet in particular wouldn't be very good at measuring how basic something is because its endpoint is in that really high acidic range. You might find other charts that look something like this that show sort of the pH range and what that middle color might be, because a lot of these indicators will have sort of a middling color. And what you'll find is that most indicators have that one turning point. Thymol blue, for example, though, has two turning points where it goes from pink to yellow, with orange in that middle range of the pH, and then yellow to blue, where it goes to a cyan color between the pHs of 8 and 9. We'll use a variety of indicators in this course. Phenolphthalein is probably going to be one of the more common ones. It's really good at determining whether something is acidic, neutral, or sort of approaching that just basic range, and determining whether it's that or a strong base where it goes that really pink color. You can use bases for a whole variety of different reasons, but we'll use a bunch of those in context throughout the topic. There are a bunch of different charts. Here's another one. They show different kinds of synthetic indicators and what their color changes are or what they look like. You're more than welcome to peruse them at your own time. The only thing that I'll indicate here as well is that universal indicator is something that you're probably quite familiar with, where it will change sort of a variety of colors from red to purple, green being neutral in the middle. Universal indicator is really good at giving a general idea of how acidic or basic something is, but there isn't a lot of precision in being able to read what the turning points are as each color sort of changes. This is why some of these indicators get used all the time as well, is because there's a really distinct point where the color changes. We're just looking at trying to identify really quickly and simply if something is acidic or basic, or how acidic or basic it is. Universal indicators are a really effective indicator at doing that, but there are going to be contexts within this course where we are going to need a really precise and accurate turning point. That'll make a lot more sense when we start actually using them in context in future parts of the module. We also have natural indicators. So, for example, we can extract the pigment from beetroot and it can change in color depending on the pH of the substance that it's in. Similar, red cabbage can do the same thing. The pigment that's in the red cabbage can change color as well depending on the acidity or alkalinity of the different substances that we might put it in. Another chart just to show that there are lots of different color changes across a range of pHs for a bunch of different natural fruit and veggie kind of substances. We'll probably do a red cabbage test in class. The last thing that I want to look at today is that while we can use these chemical indicators to really accurately measure certain pHs at very specific points, a pH probe is by far the most effective way to be able to measure pH. Generally speaking, you can get a measurement to 2 decimal places, which is quite a high degree of accuracy when measuring pH. On top of that, you can have the probe sitting in the mixture, changing, meaning that you can measure changes to the pH of a mixture, maybe as you're trying to do a neutralization reaction or something like that. Thank you very much, everyone. In the next video, we're going to be looking at energy changes that happen in neutralization. Neutralization is an exothermic process, and is something that we are going to measure practically, just like we've done before when doing enthalpy measurements in Module 4. But until then, have a good one.